Hi guys, today I will go through some examples on the three proof techniques: contradiction, contrapositive, and induction. So let's start with contradiction. So contradiction just means that you assume the opposite is true and then show that it will lead to some problems later on. So in this case, so we know that the sum of A and B is irrational, and we want to show that at least one of them is irrational. So to assume the opposite means, so you say that both A and B are rational. And this is how you present rational numbers. You let A to be P on Q. You let B to be R on S, where P, Q, R, S are positive integers. So now you can go ahead and add A to B. Replace A with P on Q. Replace B with R on S. And then you just take the common denominator. So as you can see from here, so when you add A to B, you end up with a fraction, which is rational. So this one contradicts with the original statement, which say the sum is irrational. So this one is proved by contradiction. Contrapositive is different. So you got the statement P will lead to Q. So what you do is you swap the order of P and Q, and then you negate both of them. So if you're trying to prove this statement here, so the contrapositive statement would be this. The opposite with x greater than or equal to 0 would be x less than 0. And then opposite with this inequation would be this one here. I'm not going to read it out. Okay. So from here, you need to use logic to prove. Since x is less than 0, so we can say that all of these terms are negative because they are odd powers of x. Okay. That means when you add all of these together, it should be negative. Alright, so the right hand side, as you can see, x power 4 and x squared, so they are even powers of x. So when you add them together, you should get a positive value. So from there, you can conclude that the left hand side is less than the right hand side. So by proving the contrapositive statement, you actually prove the original statement. And sometimes it's easier to prove the contrapositive statement compared to the original statement. That's the whole point of this method. Okay, the last method is proof by induction. And this one is, I would say, the most common method. And there are three main steps in this method. So we want to prove that 4 power n minus 1 is divisible by 3 for all positive integers n. It would be better hard, if not possible, to use direct method to prove this statement. So the first step would be you let n to be 1, and then you substitute it in. So 4 power 1 minus 1 would be 3, which is divisible by 3. So our first statement is correct. The second step, so you assume that for some n value, this one is divisible by 3. Now then the last step is the most important step, and you have to show the last step based on the second step. So you want to show that for some values n plus 1, 4 power n plus 1 minus 1 is also divisible by 3. And usually you need to use some algebra techniques for the last step. You want to somehow get to the second step, which is 4 power n minus 1. So let's start from here. You got 4 power n plus 1 minus 1. Okay, so we know that we want to isolate 4 power n minus 1 somehow. So this is how you do it. Because there's a factor 4 in front of 4 power n, you want to take it out, and then you minus 1. But if you minus 1, you have to add 1 to balance it out. And don't forget, you still have negative 1 outside here. So now you expand the bracket out. So put the 4 back in. So now you can see that you got 4 power n minus 1, which is the second step. And your result would be 4 times something divisible by 3 plus 3. That means the whole expression is divisible by 3. Here's another example on induction. So in this case, you want to prove that for k from 1 to n, so you can express the sum by n over n plus 1. So your first step, again, so you start from some value. Okay, so you want to basically let k to be equal to 1. That means you only got one term in this case. So you substitute in, the left hand side will be a half, and then the right hand side is also a half. So your first statement is correct. So second step, so now you assume that for some n value, so this equation is true. And the third step, so this time you go up by one step. So you let the integer to be n plus 1, and you want to show this equation here. So instead of having n, you have n plus 1 this time. Again, you need to prove this result based on the second step. So there's some algebra involved here. If you go from k equal to 1 to k equal n plus 1, so you can split this up into 2. Okay, you go from k equal 1 to k equal to n, and then you add with the last term, which is k equal to n plus 1. Okay, so that's how you get that term. And then from now, you can replace this first sum here with n over n plus 1, because that's what we assume in the second step. So now you need to take the common denominator and then do some simplification. So now you will get to here, which is what you want to prove.